Hello everyone, my name is Indranil Hatai, related to earlier course, the VLSI physical design. So here we will talk about the practical aspects of VLSI physical design, and there are that means the students who are working with the digital ASIC design, they will follow, or this course will be helpful to them. So as we have seen in the VLSI physical design theoretical course, that there are several steps which are associated with this ASIC chip design. So here in this course we will talk about, or we will see that means how this each and every steps has been developed or implemented using the electronic design automation tools. So here we are going to use several tools for designing an ASIC. Okay, so now we can start with that means though there are several companies for doing this EDA tools, that means where you can work on. Here we will talk about this synopsis. In the whole course we will use synopsis tool for synthesis, for timing analysis, for physical design, each and everything we will use synopsis EDA tool. So today we are going to start with the primary of this, that means the starting point of this VLSI physical design, which is the that means synthesis part. So synthesis part can be done through the synopsis EDA tool, which is known as design compiler. So now we can start with the basics of design compiler. So in this course I will talk about the different, that means methodology, that means how you can implement or how you can use the design compiler tool to design your corresponding design. So we will see that, and after that I will, at the end of my that means talk, we will see the demo on the tool, so that you can just follow that and you can start your work. Today we are going to start with this design compiler basic. So design compiler is a tool from Synopsys, which is basically used for synthesis. So what do you mean by synthesis? Synthesis basically means that means we have some logical expression which has been expressed through the hardware description language, that can be either that means Verilog or VHDL or system Verilog or system C. So that function, that means, or that logical expression, how that can be implemented through the gate level, that means that has been the task, or that has been the job of the synthesis part. So here we are not doing that automatically, that means we are not doing that in manually. So here we are taking the help of some that means design automation tool, so that it provides me, that means I will provide the corresponding HDL information to it, or the logical expression for my design. So it will give me the corresponding gate level netlist of that. So I can express that, that means, or I can design that logical expression in several ways. That means either that can be in the gate level, or that can be in the data flow level, or that can be in the behavioral level. So there are several representation of this HDL language, but any of this representation can be now converted into the gate level, corresponding gate level netlist through this design compiler tool. So design compiler tool is basically, that is industry's standard best. Okay, it has been used by several companies, several academicians, several researchers. So because it provides the, that means whenever I will use, or you use this tool, it provides you the optimized design which has the, that means which has the efficiency to achieve smallest as well as fastest logical expression for any given function to it. This synthesize your corresponding hardware description language into optimized, technology dependent and gate level design. So here the primary thing is that, what do you mean by this technology dependent? So technology dependent means, as we know that in FPGA or in any other method, there are, that means, pre-designed or that means prefabricated things are available to you, but here we have to use some technology file. Okay. So, technology file means there are some of the information about the basic gates which has been provided to the corresponding design compiler tool. Okay. So, that is why this tool is basically technology dependent. So, unless and until you are providing the corresponding technology, that means which gate you are using or in which foundry basically you are going to fabricate this, because at the end of the that means day or end of this that means the whole flow, we will get the corresponding GDS2 file. Okay. So, that means geometric description file of my concept or whatever logical expression or this design I am trying to or going to do. Okay. So, that is why the tool is basically technology dependent. Okay. And this tool also supports a wide range of flat and hierarchical design styles and can optimize both combinational as well as sequential design for speed, power, area, because this speed, power, area along with that the time for market. So, that is why basically as time for market is now the major concern in the industry. So, that is why this EDA tool, that means the design automation tool, that has become a, that means that is giving you a primary role for design your ASIC chips. Okay. So, here whenever we are taking the support, as we are not doing that in that means in manual way, we are taking the help of one design automation tool. So, the tool should be intelligent itself, so that it can optimize or it can give me the best possible combination or the best possible that means design of my whatever I was going to do. Okay. So, that is why this supports a wide range of flat and hierarchical design style and can optimize both combinational and sequential design. And why combinational and sequential design? That means because here this Synopsys EDA tool, whatever we are going to, that means that the whole flow, that is basically we are going to design for or we are going to use for digital ASIC design, not analog ASIC design. Okay. So, this is the, that means the features or this is the, that means advantage of design compiler. Okay. So, in the next slide, this design compiler has, that means as I said that design compiler is a product of Synopsys. Design compiler basically provides some other features. Okay. So, they are like DC Expert, DC Ultra, and then this design compiler graphical and design compiler in topographical mode. So, what are them? Okay. So, DC Expert is one of the design compiler. DC means design compiler. So, DC Expert is one of the mode. If you use this mode of design compiler, this gives you or this provides you that means the design which are optimized in respects of area, timing as well as power. Okay. And the timing here has been calculated by this loading the well load models. So, what are these well load models? Well load models are basically used, actually we will see or we will talk about this delay estimation and how these well load models are basically associated in this delay calculation in static timing analysis talk. So, here just for the, that means for introducing these words to you, I can say that well load models are the, that means models where these resistance capacitance values are stored of the corresponding technology file which we basically we are going to use. Okay. So, this resistance and capacitance value that are being used whenever we are that means calculating the corresponding delay for any circuit. Okay. So, another mode is this DC Ultra. So, DC in the DC Ultra mode, it also that means the like same like DC Expert. So, DC Expert is, if I say that, that is the basic mode of design compiler. So DC Ultra is the advanced mode of design compilers. So here how it is advanced, so that means just like the DC Expert, it can provide the optimization in terms of timing, area, power, everything, as well as along with that it can calculate the advanced delay and arithmetic optimization, advanced timing analysis, as well as it can use register retiming or pipelining. This kind of technique it can use for that means implement the circuit, though I have that means express the same function. So these advanced features can be automatically included in my corresponding gate level netlist, so that I can get or I can achieve the corresponding specification which I intended to do. Okay. So these advanced features that only available in DC Ultra mode. Okay. So this also that means uses this placement and optimization technologies to ensure better correlation with the final physical design. So here whatever we are that means talking about, if we are talking about this design compiler, so this is basically the front end design. So this known as the front end design. So this that means starting whenever we are that means generating the corresponding gate level netlist. So once we are getting the gate level netlist, so with that gate level netlist now we can move on to the physical design part. So physical design part means there are like the other steps like floor planning, then placement, then routing, all those things are there which will be covered next in the in this course. Okay. So in the early stage, as I can say that this we are now in the synthesis part. So synthesis part is the early stage of this VLSI ASIC design flow. So in the early stage of this, we can betterly calculate those delays or these power consumptions or this area or timing that can be that means much more correlated with the final physical design, though we have not yet implemented it. Okay. So DC Ultra provides that information to you. Okay. So the another mode is this design compiler graphical. So in design compiler graphical mode, it provides both the features, this DC Expert as well as the DC Ultra. It also optimizes the multi-corner multi-mode design and reduces the routing congestion. So this all these like routing congestions and this multi-mode design, multi-threshold design, these all are related to the physical design part. That means whenever we are trying to implement this floor planning, or basically whenever we are trying to develop the geometric description of my circuit, so at that time this point comes, this routing congestion and this multi-threshold voltage design or multi-mode design, so all this comes. So but in the early stage, like in the synthesis part, we can easily access those using this advanced version of design compiler, which is design compiler graphical. Okay. So it not only that means it optimize this particular like routing congestion and this multi-threshold or multi-mode design, it also improves the area correlation with the IC compiler. So IC compiler is that tool which is used for the physical design part of this IC compiler is also from Synopsys. So this is basically used for VLSI physical design part. Okay. And runtime in IC compiler and lets you create and modify floor planning. So that means in design synthesis part itself, I can prepare my design in such a way so that it can give me an outline, or it can give me a that means quick idea about how this my chip will work after the final physical design implementation. Okay. So this can be achieved through this design compiler graphical mode. Okay. So in design compiler in topographical mode is another mode. That means in the earlier things we have seen that is graphical. So here in design compiler in topographical mode, it uses the synopsis, placement and optimization technology to ensure better correlation with the final physical design. So that means in the graphical mode we have seen that is used for floor planning. So in topographical mode we can use this placement for better correlation with the VLSI physical design. So along with that, so actually in the earlier slides what we have seen, that we have seen just the basics of DC expert, but here we will talk about what are the, that means expert features, or what are the, that means the features which basically are, that means giving me all this opportunity to achieve this optimized in terms of area, power and timing. Okay. So this is this DC expert, that are basically features with this hierarchical compile mode. Hierarchical compile mode means you can compile your design in two ways, either in top down approach or in bottom up approach. Okay. So and this also provides this full and incremental compile design. So these are basically this what is this incremental compilation, what is full compilation, that has been covered in the, that will be covered in the VLSI physical design theoretical part. So here we are not talking that means in details of this particular things, but these things can be supported in DC expert. That that is the features of this DC expert. So this sequential optimization can also be achieved for this complex flip-flop design or latch design. This time borrowing for latch based design also can be achieved. Better timing analysis also can be done through this DC expert. And the best thing is that here all this DC expert that are worked in, that means command line interface or this graphical user interface is also available, but mostly we use or we prefer to use this command line interface. Why? Because whenever we are that means this whole ASIC design flow is basically run in a recursive mode. That means we have the specification. Now based on that particular specification we design the microarchitecture. So that microarchitecture that are now being covered, or that means converted into the corresponding tail level. So that at tail level now that has been converted into the corresponding gate level netlist through this synthesis part, or this through this design compiler EDA tool. Okay. So and then there are other several steps also. Okay. So unless and until, so in each of these steps it follows, that means whether we are meeting with the corresponding specification where we have been started. So it is meeting with the corresponding specification or not, that has been checked in each of this part. Okay. So that means each of the part means either after synthesis, then after that means floor planning, after placement, after routing, that means, and then final integration. So that means each of this part, end of this part, it has been checked that whether the specification has been met or not. If it is not met, then there are several other ways to how to meet the corresponding specification, but that you can do it manually, but automatically, or how we can do that can be done using this DC expert. And as this is basically actually I come to the point, that means why we use, or why we used to that means prefer to use this command line interface, as this whole process, this process is basically very lengthy. So as this whole process runs in a, that means recursive way, so that manually each and every time to do it, that is very much tedious. So that's why we can, what we can do, we can write the corresponding comments, and then as in tickle mode or in the, that means in using any scripting language. So and then that we can just pass it to the corresponding this design compiler tool. So, one by one whatever script or whatever command line we have put inside of that script, that will be executed one by one. Okay. So, that is why not doing it manually, we prefer to use command line interface for doing this. Okay. So, how to invoke the DC expert? So, if you run, that means here whenever we will use this design compiler tool, it is not run in the Windows, it runs either in Unix or it runs in that means Linux shell platform. So, okay, in the Linux shell platform, we have to type this DC_shell command to open up the GUI for design compiler. Okay. So, in the next slide we will see the corresponding features of this DC Ultra. So, in the earlier slide what we have seen that DC Ultra is the, that means DC Expert is the basic mode of design compiler, DC Ultra is the advanced mode of design compiler. So, there must be some advanced features. So, what are that, or what are those advanced features? So, this basically supports this multi-core execution for faster run times. That means, so multi-core execution of for faster run times means, so whenever we are compiling, suppose we are going to design an system on chip, which is also an example of digital ASIC. So, system on chip means there are several components and each of the component itself it is very much complex. Okay. So, each of this complex block whenever we are trying to integrate into a single chip, so at that time the whole complexity of the whole design that is increased a lot. Okay. So, whenever we will compile the whole design into the compiler, so at that time it will take too much of time, that means the whole corresponding logical expression of that particular system on chip, whenever it will be provided to the design compiler. So, at that time it will take too much of time for converting it to the corresponding get level netlist file. Okay. So, that is why this DC Ultra that are being featured with the multi-core execution, that means the corresponding job has been divided into several parts and that means parallelly, so that it can run parallelly for reducing the compilation time. Okay. So, it also provides advanced arithmetic optimization, integrated data path partitioning and synthesis capabilities. Okay. So, what are each of these terms like arithmetic optimization? So, optimization we have seen, we have known like logical optimization, arithmetic optimization, data path optimization. There are several optimization technology which is used in design compiler. So, we will see that what are those the optimization technology which are being used in design compiler. So, that I will see in the following slides, but this each of these optimization technology has been used for better performance of my intended design. Okay. So, the next features is basically advanced timing analysis and advanced delay optimization algorithms. So, advanced timing analysis means advanced like if by using the well-load models we can easily calculate what will be the, that means corresponding delay between, that means, and delay is basically that defines the timing that means specification, or that limits the timing specification of my intended design. So, that is why if that means delay wise if my specification is not meeting, so at that time I have to optimize those delays to meet my corresponding specification. So, here all these things are basically that can be done automatically, not manually. So, this provides, this DC Ultra tool provides you to do that automatically, not manually. Okay. So, it also that means calculate the leakage power, and it also trying to, that means it also helps to optimize those leakage power and that is automatically. So, along with that I can say that we can do some this advanced features like register retiming, register retiming is the, that means, process by which the tool basically moves the registers, or that means register retiming is that means I have some unoptimized or that means unintended registers placed in some paths. So I can readjust those registers, not putting any extra register to the circuit. By readjusting those registers, I can easily manipulate, or I can easily, that means, improves the corresponding delay performance of my circuit. That can be done through register retiming. So it also supports multi-voltage and multi-supply designs, and it also supports this multi-corner multi-mode optimization, which basically reduces the iteration and provide faster time to results. Okay, and that means I said it previously again, that is like this floor planning, placement, all these things can be done at the advanced stage. Though I am not using the physical design part, that means I am not using the IC compiler, but in the earlier stage, in the synthesis part itself, I can manipulate, or I can see the results, how basically my circuit is going to perform in the after working with the IC compiler. Okay, place and route mode. Okay, so that can be done. So for today, so up to this I can say, and we will see the other features of design, that means design compiler, in the next few days or in the next class. Okay, so thank you.